Today I'm going to be talking about the rise of neural speech synthesis, and we'll get into a bit of what that means, particularly from 2016 to present. And that sounds like a pretty short period, but a lot has happened since then. This is like a very broad overview of what's gone on in this period. I can't speak about exactly everything that's happened, so it's going to be quite high level. The guys asked me to keep it quite high level and not too technical, so there's absolutely no equations in the slides. I hope you're happy about that. And yeah, so let's get started. So yeah, a bit about me. My background is actually in film and music industry. I've worked on like films like Harry Potter, The Dark Knight, and as a musician I've worked with Bjork. I've done a master's in sound computing from Queen Mary, and of course doing deep learning speech research at MeetAI. So what about MeetAI? What is MeetAI? Well, we create hyperrealistic speech technologies. And so what does that mean? That means speech that is expressive, emotional, human, natural, has intonation and prosody and rhythm that reflects the human's speech. And at the moment we're a pre-seed stage startup. My co-founder is Sinead over there, putting her hand up, who's a fantastic CEO. And we are incubating at Entrepreneur First at the moment. So this is an accelerator that's based in Bermondsey, and they've got a slightly different model of doing startup acceleration where they get a lot of individuals, some of them are here at the moment, who sort of pull together, set up companies, and then take them forward from there. So slightly different in that not everybody comes in with a company. In fact, most people come in as individuals. So that's the website. We'll do a little bit of speaker demo later on. But first of all, what motivates this talk? So this talk is about, like, well, can a machine speak like a human? And it's particularly focused on how the machine says things, rather than exactly the things that the machine says. So it's not necessarily the words, it's more, can you make speech that's really, really natural and expressive and emotive, and yeah, it's the how you say it, not what you say. So this, of course, is HAL from 2001: A Space Odyssey, Stanley Kubrick film from the late 60s. If anyone has seen that film, HAL actually sounds really great, and it's actually just an actor rather than a robotic voice. I don't know if robot voices are as good as HAL yet, but that's definitely where we want to get to. So I think Stanley Kubrick was like well ahead of the curve there in terms of his prediction for the future. So very quickly, oh, well, hands up, who knows what speech synthesis is? So I can run through a quick Wikipedia definition. Speech synthesis is the artificial production of human speech. So it's more easily explained by, say, like a computer system used for this purpose is called a speech synthesizer. So a famous professor that we'll chat about briefly next, he used a speech synthesizer machine to speak. And another phrase that's used in this research domain is a text-to-speech system. Converts normal language text into speech. So text-to-speech is what you think. You enter in text, you get speech, audio out. So an example of what speech synthesis is. Curiously silent. Poor Professor Hawking. He'll be back soon.
called the event horizon. A black hole has a boundary, called the event horizon. It is where gravity is just strong enough to grab light back and prevent it escaping. Because nothing can travel faster than light, everything else will get dragged back also. Falling through the event horizon is a bit like going over Niagara Falls in a canoe. If you are above the falls, you can get away if you paddle fast enough, but once you are over the edge, you are lost. There's no way back.
So, that's Professor Stephen Hawking, and did anybody notice anything about the sound quality of his voice? Does it sound natural to you? Does it sound like a human? Not really. Yeah, it's quite unnatural, and it's not really realistic. And it's interesting with Stephen Hawking because he actually had multiple opportunities to change his voice to sound better. He stuck with the same synthesizer that he had for years and years, particularly because... What's that?
It's a signature.
It's a signature, yes. It's his voice now. And also that apparently his friend made the system for him, and it was very advanced at the time, and he wanted to stay true to his friend's creation as well, which I thought was a really nice story. But not quite realistic, and we'll move on to say, in 2016, DeepMind brought out WaveNet, which was a really, really interesting piece of research that essentially, on a technical level, it predicts the next audio sample conditioned on the past. So that's a bit of a technical mouthful, but essentially what it means, if you look at the diagram here, these are audio samples, and audio samples can be thought of as sound atoms. And to recreate a sound, you need about 20,000 to 40,000 of those running by every second. So that's a huge amount of number crunching to do to generate this sound. So it's saying, on a very, very high level, given all the audio samples that have occurred in the past, what will the next one be? And it does that, say, 20 or 40,000 times a second. So that's like quite a lot of number crunching. So they previously thought that that was impossible, like a very tough mathematical problem. But with what the DeepMind guys showed, it's Aaron van den Noord and company, they showed that it is possible through the magic of convolutional neural nets. So what does that all mean? Well, it sounds great. So that's the real value in this, is that this method of speech synthesis of creating artificial speech sounded really, really good. So we'll have a quick listen to that. So I'll play two non-WaveNet synthesizers, and then I'll play the WaveNet synthesizer, and you can hear for comparison. So this is not WaveNet.
Aspects of the Sublime in English Poetry and Painting, 1770 to 1850.
So it's a little bit robotic, perhaps. The second one this is also not WaveNet.
Aspects of the Sublime in English Poetry and Painting, 1770 to 1850.
So it's a little bit more realistic. And then the WaveNet.
Aspects of the Sublime in English Poetry and Painting, 1770 to 1850.
So it's much higher quality and much more natural sounding, and much more realistic in terms of its humanness. So, which is great. And what WaveNet brought really was the quality element that wasn't really there before. So previous methods, there were many, but like one of the ones you just heard involved stitching together small samples of people saying small components of speech called phonemes. You stitch them together and blend them together, but they tend to sound a little bit robotic, as you've heard. So the WaveNet brought this realism, which is fantastic. But is there a problem with this? Well, I wouldn't necessarily call it a problem, but there was improvements to be done, and that was that the WaveNet was really realistic, but not that expressive in terms of its more emotional content and this sort of expressivity that you would expect from a human voice. You know, the ability to do lots of different types of emotional meaning with the subtext of the voice. And so we'll go on to see next something that's solved that somewhat, which is something that I've called the Techtron Explosion. I call it the Techtron Explosion because Techtron is a bunch of research papers, not just one research paper, but 10 and counting, and they seem to like release one every month from Google, not the DeepMind research group, but from the States. And there's way too much to go through now, but I'll just show you one of the papers. And they're doing lots and lots and lots to really try and drill down on this expressivity. Not all papers are like have exactly perfect results, but they're all really interesting in terms of their contributions to the field. In particular, they brought this idea of a spectrogram to vocoder structure. So the vocoder is essentially a WaveNet, and that controls the realism portion, and the spectrogram is essentially controls the expressivity and the emotion of the dialogue. So you can think of the spectrogram component as the sort of wireframe prototype of speech, and the WaveNet vocoder then renders it in really high quality, high fidelity. So more control of prosody, intonation, and other expressive measures, and just generally more expressive. So let's have a listen to. I thought this one was particularly interesting. This was called Style Tokens, Unsupervised Style Modeling, Control and Transfer and End-to-End Speech Synthesis by Wang et al. And what was impressive with this was they created these components called style tokens, which were like parameters on which you could vary the speaking style. And these were learned by the machine learning algorithm, not necessarily defined beforehand by the programmers. Let's have a listen.
Thinking that he should probably wait for Filch to come back, Harry sank into a moth-eaten chair next to the desk. There was only one thing on it apart from his half-completed form, a large, glossy purple envelope with silver lettering on the front.
So these are audiobook phrases, as you can imagine. So this lady is talking about the moth-eaten chair. What's interesting, though, is that they created a system where you could modify these style token, basically levers, and change the way that it is presented.
Would probably wait for Filch to come back. Harry sank into a moth-eaten chair next to the desk. There was only one thing on it apart from his half-completed form, a large, glossy purple envelope with silver lettering on the front.
So what's interesting is it's a totally different style, it's a different type of expression, and yes, it's really, really impressive the way that they were able to separate those styles and have those as controls. So yeah, that's, and they have 10 more papers and counting, and they'll probably release another one in December. So definitely a really interesting portion of the research that I wanted to mention. So, and this brings us to some of the work done at MeetAI, which was, in particular, these models are expressive, which is great, and that's what we want, and they're realistic, and we get that from the WaveNet, the WaveNet research. But the when you're training these machine learning models, they're fixed to a certain sort of finite number of speakers, maybe like 5 or 10. And these are individual people. So if you want to add in a new speaker, you have to retrain the machine learning model. And if you've ever done any machine learning on large models, it can take days, if not like over a week sometimes. So it's a huge, long iteration cycle that's quite difficult to work with. So one of the things that we at MeetAI wanted to do was to see if we could create a system that you would only have to train once, and it could work with any number of speakers. So that brings us to, we're still working on the name, but the general neural speech. So it combines, builds off the research of WaveNet and Techtron, so we have the expressivity and realism, but it's compatible with any speaker and doesn't require any retraining of the model. So that's essential if you want to then iterate quickly and not spend another hundreds of compute hours again on retraining the model. So we can have a quick listen of this.
Everything's in the right place, you can't go wrong, which makes the Buick Enclave such an easy choice. It's full of features like the IntelliLink voice-activated sound system.
So that's obviously a advertising style, and the advantage of this was, or what's maybe not so apparent, is that this voice wasn't in the training data of the machine learning model. So this was held separately as test data. It's a little bit technical, but it's all to say that the model that we created can now generate new, different types of voices, or be applicable with voices that it hasn't seen before, without being retrained again, spending hours and hours of compute cycles to retrain the machine learning models. So yeah. So of course, in half an hour or so, we haven't exactly fully answered this question. Can a machine speak like a human? But I think it was good to just do an overview of what's happened in the research, a little bit about what we're doing, and I suppose the answer is sort of yes, but also there's still plenty of room for improvement, and there's lots of interesting research still coming out. So I think it won't be very long before things like assistants, Ollies, are speaking with full human fidelity, if that's in not that long a time, because the research is already there in terms of the quality and the expressivity. So I think it's going to be very soon. So there's potentially room for improvement, and there's plenty of super clever people in this room, I know that for sure. So this is where you come in. So get in touch with me if you have any questions or you want to chat on any of this. As I said, we're a company that are incubating an entrepreneur first now. We'll be hiring in 2019, but also in general, if you have any questions, like I love talking about this stuff, so send me an email just to say hello, or we can chat afterwards. And yeah, so thank you very much.